I want to introduce my co-authors, Abul Masunda. He was the PhD student, former PhD student, and also we worked collaboratively with the Attorney Consulting Group. Dr. Neil Burke is represented by TCG, and this study was funded by the Michigan Department of Transportation. So we'll go through a little introduction to understand the need, and then the objective. We will look at the experimental program, and then how to identify the age of new concrete to receive an overlay. And part of that is the performance evaluation. Then finally, the summary and recommendations. So typically we use epoxy overlays as a capital preventive maintenance activity. In order to apply these overlays, DOT specifications and the special provisions require the contractors to wait until at least 28 days. So this conflict with the traffic and weather limitations. So we wanted to reevaluate whether we can apply these overlays before the end of the dry curing period. That means before the end of the 28-day age of concrete. So typical application procedures involve surface cleaning, shot blasting, and surface cleaning. Then we need to check the moisture evaporation in order to understand if the rate of moisture evaporation is acceptable. And then we apply the overlay in 2 coats. Within each coat, we apply aggregate, or we broadcast aggregate. So typical rates of what we call the surface preparation and production rate, we need at least like 1 hour. We can clean about 600 to 850 square feet. When we apply overlays, within an hour, we can apply about 1,000 to 3,500 square foot per hour. So, but we need 2 hours at least as the curing period between each overlay. So if we look at a typical project, this will require at least 2 days, depending on the size of the bridge deck. We can look at 2 sites to understand the impact of applying this early on. So basically, we're looking at the cost saving if we can apply the overlay before 28 days of concrete age. So this is one site where we had a bridge with more than 5,800 square feet. And then specifically for this site, the drivers, the passenger vehicles and commercial vehicles have to use 2 different routes. So the user cost is going to be significantly different from a typical site. Like this one, as a typical site, we can consider where we have commercial as well as the passenger vehicles use the same route. So this is a site on a freeway. The previous one is on a local road. So this one has more than 4,600 square feet area. So when we look at the user cost from each project, this is the rural bridge, and this is the one on the freeway. So you can see it cost about 30,000 for the users on one bridge, and the other one is about 85,000 US dollars per day as the user cost that we can save. If we can reduce the closure duration per day, this is the saving only from the user cost. And typical operation, when we look at for these 2 sites, it takes minimum 2 days. So if we can finish the work in 2 days, it will cost the users 60,000 to almost 169 or 170,000 US dollars. So this shows the impact. So typically when we are doing overlays and repairs on bridge decks, if we have new concrete, we have to wait for 28 days with the typical concrete to have the curing duration satisfied to open the bridge. So if we have to go beyond that, this is the cost going to be. So we are looking at, can we apply these overlays before we finish the dry curing period? So over there, we were looking at, do we need to have a procedure to decide the concrete age to receive an overlay? Or can we set a time telling that, okay, we can go with 21 day or 24th day, or we had to wait until 28th day to apply the overlay. So in order to do that, first we have to understand the parameters that's going to influence the performance of an overlay, or in other words, the application time of an overlay. So first thing, concrete, we need to cure it, but we need to look at strength as well as the durability. So in that case, strength is one parameter we typically evaluate, compressive strength. And then we had to look at when it's going to develop a discontinuous pore structure with the smallest volume of permeable voids to have a durable day. So we were looking at all three parameters to decide on the concrete curing duration. And then we need to look at the cracking age of concrete, because if concrete is not cracked, it's going to crack at one point. So we want to apply overlay after concrete cracks. Someone can say if we apply overlays, it may prevent cracking. That's not the case. We can show evidence, and we'll have evidence in a couple later slides. So you'll see that we have to wait until concrete cracks. And then also we have to have a certain level of moisture, tolerable moisture levels in concrete in order to apply epoxy overlays. So that there are different methods to evaluate moisture content in concrete. So we were looking at that to decide the time parameter. So those are the times T1, T2, T3. In addition to that, concrete needs to have a certain tensile strength. And typical, what we expect is more than 250. The reason for that is after we apply overlays, the performance is evaluated by conducting a direct pull-out strength test. So in that case, we want to have bond strength more than 250. So concrete needs to reach that strength before we apply overlays. So that's the fourth time parameter. Then the last one is the performance of overlay itself. We evaluate that with the bond strength. So in that particular case, we can apply overlay at different ages and of concrete and try to find out at what age we will have the bond strength greater than 250. So that's the fifth time parameter. So out from all these, we need to have the greatest value as the age of concrete. So we develop an experimental program by using all these parameters and to evaluate all these parameters. For that, we use 2 epoxy overlays, and we consider 2 concrete mixes. One with supplementary cementitious material, slag as a supplementary cementitious material. The other one only had type 1 cement. So when we look at the curing duration for the mix with slag, we need to go up to 10 days. So typical curing duration is 7 days, because by 7 days, we will have all the strength values satisfied. But in order to have a durable concrete, we need to have the minimum permeable voids and the discontinuous capillary pore structure. So that we can evaluate using bulk electrical conductivity and the porosity testing. So with that, we can determine the minimum curing duration. In this particular case, with the mix with slag, we need to wait at least 10 days. This is wet curing duration. For the mix with type 1 cement, actually 7-day moist curing is adequate, because we can have a discontinuous capillary pore structure little after 3 days, and the minimum permeable voids we can see around 7 days. So with that, we can discontinue wet curing after 7 days. So it depends on the mix. So as I mentioned previously, in order to apply overlays, we want to have concrete cracked, unless we use some other concrete that will never crack. So it's not the case with typical concrete, it's going to crack. So we need to evaluate the cracking age. So this is an evaluation in the lab rather than in the field. So in the lab, when we use grade DM, that means the mix with slag, it's going to crack after 20 days. We ran a couple shrinkage rings. So we can see we had to wait at least 28 days before we apply overlay. For the mix with type 1 cement, it shrinks more than the mix with slag. So that's obvious. So it'll crack after about 18 days. So if you're going to apply an overlay on concrete with typical type 1 cement, then we need to wait at least 18 days according to laboratory conditions. So field conditions can be different. So as I mentioned previously, someone can say, why don't we apply overlay? Because it's going to trap moisture and it will enhance the strength and it will reduce the cracking potential. Yes, cracking potential will be reduced, but it can prevent cracking because we use overlays on crack rings and they started cracking. Yes, took longer, but still cracked. Once concrete cracks after overlay application, it will be very hard to inspect and identify. So because of that, we had to wait at least the concrete cracking age to apply overlays. The other parameter is the moisture content. Typical industrial rate for flooring is looking at 3 pounds per 1,000 square feet within 24 hours. It's called the moisture vapor evaporation rate. And then there are some specifications looking at moisture content. So it can be less than 4.5 or 5%. And we evaluate the moisture content using electrical impedance meter. So with this, we evaluated moisture content in 2 mixers as well as a moisture vapor evaporation rate. So when we look at the moisture vapor evaporation rate, this is under laboratory conditions. With grade DA mixers, we never reach that limit. That's strange. Okay? With type 1 cement, we could. But when we look at the moisture content, we can achieve that level of 4.5 or 5% limit within around 14 days in the mix with slag and about 17 days in the mix with type 1 cement. So we can go with the specifications that require moisture content or specify moisture content as a limit to apply overlays. In that case, we need to wait 14 days for grade DM and 17 days for BDJR, means the mix with type 1 cement. So the last one is to evaluate the performance of the overlay. So we want to have minimum bond strength of 250 PSI. So what we did was we evaluated the bond strength under room temperature and also elevated temperature. We subject the overlays to wet and dry cycles. In this case, we use 3% sodium chloride as the medium for wetting the surface. And also we place the specimens outdoor and conduct the testing during fall, winter, and summer. So the application age of the overlay the concrete age at the time of overlay application was 14, 21, and 28 days. Because typically we had to wait minimum 28 days. So we used 28-day performance as the benchmark. But then we compare the performance when we apply overlay at 14 days of concrete age and 21 days of concrete age to see if there's a performance difference. So if there's no performance difference, we can select a time period within this range so that we don't have to wait beyond the 28-day closure. So we can open the bridge just out on the 28th day and save money for the users. So in the lab, we use infrared lights to heat up the slabs. And this is showing how the temperature is going to increase in the slabs with multiple lights. And then we get the slabs. These are the almost like 4 feet by 4 feet, 9 inch thick slabs with overlay applied. There were like 50 some slabs. So they get exposed to summer and winter conditions as well as 3% chloride during winter. So then the bond strength evaluation, we use the standard ASTM method C1583. We like to have type A failure. Failure should be in the substrate. But if the substrate strength and the overlay bond strength is greater than 250, it may fail somewhere. Especially this type D, when we have the adhesive between the disc and the overlay, it may fail at the glued surface. So in that case, if the strength is greater than 250, even the failure is D, we take that data because we know the strength of the system is greater than 250. So when we look at overall results, irrespective of the overlay type, epoxy type, as well as the concrete, you can see under room temperature, strength is greater than 250. So this is the mark for 250. Even if we subject it to wet and dry cycles with sodium chloride, still the bond strength is not compromised. So temperature is the biggest factor. When we heat the slab to about 120, 110, 120 degrees, bond strength significantly decreases, and all the time we see bond strength less than 250. And then once we let it cool down, bond strength recovers. That means there's no permanent damage. So there should be some temporary damage or material reduction in material behavior or strength with elevated temperature. So when we look at concrete mixes and the bond strength, so you can see this is with slag. So it shows little higher strength compared to the mix with type 1. So that's obvious because at the early ages, we're going to have more moisture coming out from type 1 cement concrete compared to grade DM, because grade DM has very tight pore structure. And also we compare the two epoxies because they have distinct properties. One is the viscosity. This epoxy had low viscosity and also is more tolerable for the temperature. And I didn't include here, but we did the glass transition. We evaluated glass transition temperature and several other properties under of these overlays under elevated temperature conditions. So that shows that this epoxy is more stable under elevated temperature, but still the performance is not adequate or satisfactory. So the failure wise, typically we like to have type A failure in concrete that we see under room temperature, as well as under wet and dry cycles. But under elevated temperature, we see the failure at the interface. Once we let it cool down, it reverts back to the failure in the substrate. So that's a good sign. And then outdoor also during summer under elevated temperature, we see the failure at the interface. So this one is showing the mix with slag and two different epoxies, and the application ages as 14, 21, and 28 days. So in this particular case, so what you see is this is more like early age performance, and then this is the outdoor performance. So even though the performance bond strength is less than 250, at least it shows little better performance compared to the laboratory, because we had continuous heating and cooling cycles over here, and also concrete had little higher moisture compared to very aged concrete, because this is more than like a year, okay, 519 days. We have 300 some days for a year, so this is more than a year. So we can say little mature concrete with low moisture content. So we see the same performance. Once it cools down, yes, it's going to revert back to gain the strength, required strength. And also when we test it under freezing conditions, we see higher strength. So the biggest factor is the temperature. And this is when we have type 1 cement, bond strength is lower than the one with the slag. Okay? But still, we see a little better performance with one epoxy that has little temperature tolerance, as well as low viscosity. So it is easy to apply and help enhancing the interface. So when we look at possible reasons, one we can see in grade mix with slag and type 1 cement. So there's significant increase in moisture when the temperature is more than about 90-95 degrees Fahrenheit. So there's significant moisture that attracts towards the surface. In this one, it's lower. The moisture content, the increase in moisture is lower. So that's why we can see there's a performance reduction in BDJR or mixed with type 1 under elevated temperature. And this is within like first 100 days, so 150 days. But when the concrete get matured, most of the moisture is used for the hydration purpose, because these slabs were all sealed around except except having the overlay on top. That means the entire specimen is sealed, including the bottom. So there's no way to get additional moisture into the specimens. So with the age of concrete, we can see very small increase in moisture content even with high temperature. So we see some better performance as concrete get older, but still we see the lower bond strength. And as I mentioned, I didn't include the results here, but we can see that with the kind of like material softening with elevated temperature. So based on the parameters that we use for the evaluation purpose to identify the concrete age to receive an epoxy overlay, when we look at all these, cracking age is going to control. Okay. Curing age, yes, it can be like 7 or 9 or 10 days. And then the application age, we the cracking age is 20 and 18. Moisture content will stabilize after 14 days in grade DM and 17 days in mixed with type 1. Concrete tensile strength will be gained less than in 7 days, both mixes, so it was not a concern. And then the last one is bond strength. So irrespective of the application age, we consider that's 14 day or 21 or 28 days. We saw similar performance. So even applying overlay after 14 days is fine, but concrete is going to crack later. So in that case, we had to use the concrete cracking age as the concrete age to apply epoxy overlays. But this will be different in the field. So what we are going to do next is really going to do this, duplicate this work under field conditions on coupled bridges and try to see how the performance is going to change. So this is the framework that we use to evaluate the concrete age to receive an epoxy overlay, because our objective was to look at whether we need the procedure or a set time. So this shows that we can go with the set time because it depends on the mix design and the exposure conditions. So because of that, we can say we need the procedure, and this is the framework or the procedure that anyone can use to evaluate the application age. And we see better performance with low viscous epoxies. So because of that, ease of application and having a little better bond, we recommend that. According to the current results, we need to wait 20 days for mix with slag to apply overlays and 18 days for the mix with type 1 cement. But that is based on cracking age and it can change. We prefer to have supplementary materials in these mixes because that's going to enhance the bond strength. And then by looking at all these right now, we can say you can apply this overlay after 21 days because that will cover the cracking age, and still it is earlier than 28 days. So you will have a couple days to finish all the work and open the bridge on 28 day instead of going a couple days beyond the 28-day closure period. So this way we can save money and still get the similar performance. I don't say the performance is going to increase unless we find material that's more tolerable for temperature and also find other ways to enhance the bond strength. So using some fibers or something in the mix as well as overlay. So we need to do a little more work in that aspect, but with the current state of the art, we can apply it before 28 days and save money from the users as well as for the agencies and the taxpayer money. So that's the end. Thank you so much.